2.1 we're on still.
I love this lesson.
Let's hope that was recorded.
Wait, are we recorded?
So,
We're recording.
we
Tell
talked
us if we're
yesterday.
recording, seriously. I'm concerned.
Yeah, we're recording. I just said that.
Are we recording now?
We talked yesterday about displacement, okay? So, what's up? Got your notebook? Write out something else for him. Borrow a piece of paper. Can't recognize this list. Gotta do it right away. So yesterday we talked about displacement versus distance. Somebody give me a quick summary as to what the difference is. Chaz.
This is how far you actually travel, and then the displacement is where you went. So, for example, if I walk across the wilderness in like a zigzag, that'd be my distance. But if this is point A and that's point B, then that'd just be displacement.
Very good. Again, displacement is literally a line between 2 points. The distance of that line segment, or the length of that line segment. But distance traveled is the path you take. Okay, very good. Today it's going to incorporate that as well. That's why I'm reviewing it. Yes? Sure, you can, but you have to be very specific. Okay? So you could say that the displacement was a length of instead of distance maybe. And better word to use there, just to not confuse it. Okay, just be careful. All right, so you've learned many times before, and you've seen this in middle school and then Algebra 1, and then you're probably going to see in Algebra 2 again this year if you haven't already. But the standard problem is distance, rate, and time. Okay? So you know this simple problem where it's distance equals rate times time. You've seen that many times before. Okay, today we're going to look at an alteration of that that has to do with velocity instead of rate. So, what we're going to talk about today is velocity. Velocity equals delta t over, delta x over delta t. And let me explain where this comes from for you. So, if you were to solve for r over here, go back to, your Algebra 1 / middle school math problem. If you solve for r, you would divide by t and divide by t. And you would get the rate equals the distance over time. It's very similar to what we're looking at today. But now, instead of distance, we're looking at delta x, which as we know from yesterday is displacement. Delta t is still time, except we use a delta symbol, because now we're in physics, and we know that means tf minus ti. Okay? And v now stands for velocity, as opposed to r, which we call rate. But really what this r is really s, which really stands for speed. Okay, and then this is velocity. So I'm going to give you an example to begin so we can understand the difference between velocity and speed. And there is a difference, which is very odd to think about. Because usually we use the words interchangeably, right? You might say, what was the velocity of that fastball? Well, it was 96 miles an hour. Or, well, what speed is your car, or are you driving your car? 55 miles per hour. But nobody really understands the difference between the two until you start studying physics. So let's start with an example. So again, velocity is displacement over time. Speed is distance over time. This is distance for D here. Again, this is distance. This is displacement. You know the difference there. So for the example we're going to look at, let's say you travel across the country. Okay? We have these formulas written down, people? Okay, you travel across the country. And you travel from New York to Southern California. And you take the northern route up through, say, Wyoming, North Dakota, maybe up to Canada, through Washington State, and then back down. So we start again in New York over here, and we finish in California. The distance traveled, as Chaz said, would be the literal distance along that curved path. Whereas the displacement from yesterday, we know, is just simply a straight line connecting those 2 points. Again, the smart board is freaking out in the middle there. It is a straight line. I know it doesn't look like it.
Why wouldn't you just take that?
You can't always drive from one place to the other, right? Sometimes you have to take highways because there's no highway that exists that cuts diagonally across the U.S. So to take that path, you'd be driving like 30 miles an hour on side roads. So instead, a lot of the time, you take a path like this, where you can drive, say, 60 or 70 or more. On these routes, you can drive like 85, 90, but it's a longer distance. But in the end, it's a shorter period of time. It's a good question. Why would you do that? Very true. So what I want you to do is the following. I'm going to tell you that the distance traveled along this path is 3,000 miles, while the displacement from A to B is only 1,500 miles. So again, the distance traveled is 3,000 if you take the path. If you just simply look at the displacement, or the net change of the delta, that's 1,500 miles. Let's say that it takes you 2 days. 2 days to make this trip. I want you to find the velocity and the speed. Find the velocity and the speed. Okay, in units of miles per hour. Okay, using the formulas you're just given, I know this is a little bit tough the first time, and you think you can all do it. Determine what the velocity is, determine what the speed is, and I'll tell you now they're different. They're different numbers. Determine the velocity, determine the speed in miles per hour. So make sure your units are correct. Okay, make sure units are correct when you're working through this problem. 2 full days. So literally as if you drove 48 hours straight. 2 full days. Okay, 2 full days. Think about your formulas that you know. Think about how you can utilize them to help you. Bless you. Yeah, just. Need help? Work with the person next to you. Still on final position, so my displacement is actually 0. Whereas my distance might be like 10 feet plus another 10 feet, so my distance would be 20 feet. My displacement is non-existent. So in this problem here, what we're saying is that if you take that weird path, the distance traveled is 3,000 meters. But the displacement is literally from here to here, whatever that value is. So yesterday we came up with the conclusion that your displacement is always going to be less than your distance. So you could go, like, you could do 1,000,000 laps around the city, but if you end in the same spot you started, your displacement is 0. But your distance is some very large number. And then we talked about spaceships going around the Earth and so forth. You gotta watch the video, okay? That helps. Alright. First part. Velocity. Somebody raise their hand and tell me for velocity, Gabby. What am I gonna do for velocity, Gabby?
Miles over hour.
Okay, so what are my miles?
200 miles. And 2 days is 48 hours.
Okay, so you're just going to put 48 hours here, that's fine. Guys, whatever that noise is, pause it, please. What do we get when we divide 1,500 over 48? Yeah?
62.5.
62.5. Everybody agree?
No.
Okay, I heard no. Erica, what do you got?
It's 31.25. Sorry, just 2,500.
Gabby, which answer did you give me?
I gave you the
Okay, so just be careful.
So silly, Gab. I know.
31.25 miles per hour. Okay, that's our velocity from here to here, believe it or not. Now, the speed. Tristan, you got this one. I saw you. What do you got for speed here?
62.5. Oh, well, 3,000. About
3. Good. 62.5 miles per hour. So what do you notice? What do you notice about these two numbers, Helen?
Well, the speed, you are traveling like exactly double velocity.
Yeah, notice the speed. The speed is actually exactly double the velocity. Why? Why is the speed double the velocity? Helen, follow up.
Because the velocity, you are traveling less miles. If you're traveling the less miles in the same amount of time, then you're traveling at a slower pace.
Good. And look at the numbers. Why is it exactly half the speed of the velocity?
Because the distance is exactly double
What's
the
the other word?
displacement.
It's not always the case, no. Now, again, notice the correlation here. The distance happened to be double the displacement. Therefore, the speed happened to be double the velocity. Now, yesterday we made a statement, and our statement was as follows. We said that the displacement will always be less than or equal to, it's the board, guys, less than or equal to the distance traveled. Now, use what we just said today to make another statement based on that. What can we say, Gabby?
That velocity is less than or equal to the speed.
Well done. Okay, the velocity is always going to be less than or equal to the speed. Because again, the velocity takes into account the fact that you're only moving theoretically between 2 points. Whereas the speed takes into account the route you took, the route along the way. So it's longer. Okay, so when the displacement, since its value is only from here to here, the velocity is going to be a smaller number because it's like you didn't travel as far. Okay? Just like if the distance, because the distance is this longer path, the speed is going to be as if it's a higher rate to cover that longer path. What's that?
So how do we set up the velocity problem?
So how do we set up the velocity? What do you mean?
Delta
Yeah.
x over delta t.
But what is delta x over
Okay.
Delta x is the displacement, and delta t is the time, which is 2 days.
Oh.
Delta x is, as Kareem said, the displacement. Delta t is the time it takes. Okay? The time it takes.
You have to multiply them?
Divide. We're seeing a division sign
And
there.
that's why there's...
Okay? Helen.
Wait, I have 2 questions.
Okay?
Well, actually, no, the first one I actually think is wrong. But the second one, say it was like 1,500 miles for the first one, and then it was 4,500 for like the distance. It'd be triple. It always. So you could do it like that
If you know that one is triple the other, you can find the other by looking at the factor. Absolutely.
Okay.
Absolutely.
And also, like, say you divided. I think this is wrong just because it's just for the problem.
Okay.
If you divided.
People, come on, listen.
If you divided. No, actually, this is definitely wrong. The 3,000 by 2 because it took 2 days, and it came out to 1,500. Like, if you divide.
Oh,
If
no.
you divide the distance.
Happened to be
by
a
the
factor of
time-
2 and it happened to be 2 days. Just coincidence.
Oh, okay.
Just coincidence. All right, let's go on to another one. Respond for a minute. All right, so the next problem we're going to look at, and I want you to write this down. I'm going to dictate. During a race on level ground, meaning there's no elevation change. So during a race on level ground, Jamie runs with an average.
How do you spell Jamie?
Whatever way you want to spell Jamie. Jamie runs with an average velocity of 6.02 meters per second. 6.02, I'll write the number. Meters per second east. East. Remember from yesterday that east, that's E, I know, the board is not agreeing. It's E, east.
Okay, we know what it looks like.
Remember, east is positive, west is negative, north is positive, south is negative.
Are you positive?
Okay? I am positive. What's that?
Why?
Why? because remember the coordinate plane, okay? East is really this way, west is here, north and south. Think about your XY axis, okay? So 6.02 meters per second to the east. Next, what is, we're writing still, people, what is Jamie's displacement?
Wait, sorry.
What is Jamie's displacement? Yes, right after the period, after east. What is Jamie's displacement after 2 minutes and 17 seconds? What is Jamie's displacement after 2 minutes and 17 seconds?
That's a period, or a question mark.
Question mark, yes.
Yeah.
That's typically at the end of the
Relax, relax, relax. Be nice.
Done.
Now, we don't need to talk between every pause. Let's go. That's why we run out of time in this section. I like talking sometimes, but we have to focus. All right, first of all, somebody give me some given information about this problem. Erica,
Well, the velocity was 6.02.
good, and it's positive, right?
Yes.
Good, because it's east. What else do we know, Erica?
That she runs it. The time, or no, the time that passed is 2 minutes and 17 seconds.
Good.
So then it would be 6.02 is equal to.
Relax, relax, 1 sec. What are we looking for, Erica?
You're looking for delta x of the displacement.
Very good. Now, somebody else, thank you for the head start. Can I start this problem just yet? Emmett.
no, because it's 2 minutes.
Good. Look at your units right away. You cannot do this because you got minutes here. This needs to be in only seconds. That's why I stopped you. So, Emmett, tell me, what is it in only seconds? How many minutes, how many seconds are a minute?
137.
So this is how many seconds, this part?
That's 120.
Good. Okay? Remember, this is what you're doing here. You're really doing 120 seconds plus 17 seconds. So delta t is 137 seconds. Now that we've done that, we can move on to our next step. Now, the next step, this next part here, I want to show you something that you might not think to do right away. First, since we're looking for delta x, what we should really do is solve the equation for delta x first, before we put in any numbers. So, our equation is v equals delta x over delta t.
Oh my god.
Okay? I want to solve for delta x, and I'm going to get this, it's called the generic or general solution.
Bless you.
Get the general solution.
So would it be velocity times delta t equals delta x?
Very good. Multiply both sides by delta t to get rid of the delta t's, and you're left with delta x on the right side. So you have delta x equals delta t times the velocity, and it does not matter what order you write them in, because we know multiplication is commutative. Okay? Either write v times delta t or delta t times v. So we're going to use, now underneath here, please write down general solution. Because you solved for delta x. This is the displacement, but it's in variables only, right? I'll move it up so you can see each other.
What's
Sorry.
called general
The
displacement?
general solution. So if you had any problem where you're looking for displacement and you're given velocity and you're given time, you can find it by using this general solution. Now, we need to think about the specific problem we're working on so we can find the specific solution. So we can now plug in numbers. Okay? Green, step me through.
You do 137 seconds times 6.02 meters over seconds.
Good. Very good. What do we get? Kareem?
I don't do that.
Somebody have a calculator want to check? Hunter? What else? Hunter, this one? Point what? 0.74. And Hunter, what are my units in here? Why? Very good. And it's not just the answer because it's distance. It's because the seconds cancel. Take a look. Cancel, cancel. I'm left in meters. Okay, I'm left in meters. Now, think about this logically. The original problem said the velocity was 6.02 meters per second east, which means positive, right? And notice my answer is still positive. So I should really probably put a positive sign here to indicate that it's still east. What if the problem had started and said west instead? Smilla, what would the only difference be here?
Negative.
Very good. Again, had the problem started off by saying west instead of east, you don't have to write this, but had it said west instead of east, when we did the problem later on, we would have really had to put a negative here in front of the 6.02, which would have given us a negative answer there. Okay? If it had said west. If it had said west. And a what? Sure. So displacement being negative is like me going from here over to here. My distance traveled is only 3 feet, but my displacement is negative because I moved to the left. And just like yesterday we talked about, if I walk 5 feet this way, but then I come back another 8 feet, I've got a net 3 feet negative. Okay? Because I'm going west, not south, to west. Okay? West. South. Yes. It's given. The problem is given as 6.02 meters per second east. Just plug in the time, plug in the velocity, and multiply. Okay, it's a very basic problem here we have. Questions so far?
No.
All right, next one.
Thank you.
Next one. Draw yourself the first quadrant in a graph, please. Okay? Label your vertical axis. Notice I'm using the word vertical. I'm using the word vertical instead of the y-axis. There's a reason I'm not saying y-axis, and I'll explain that in a second.
Good thing I know the difference between vertical and horizontal.
That is a good thing, huh? It really
You
is.
just learned the other day. Good thing I learned today.
So along the vertical axis, we have position in meters. Along the horizontal axis, we have time in seconds. Now, let's say that we have several increments. Give yourself 4 or 5 of them on each one. We'll say that on the vertical axis, these go up by increments of 4. On the horizontal, by increments of 2. All right, again, my horizontal axis is time in seconds. My vertical axis is position in meters.
Wait, so did you say it goes up by 2?
I'm going up by 4s here, and I'm going up by 2s here. Okay, just so you see the difference. My intervals are different. Now, before I begin the problem, from yesterday, the word position was synonymous for what? The word position, what was it synonymous for? If I said my, what is it? Very good, Steph, displacement. Because if I said my position changed from here all the way over to here, my position change is my displacement. Okay, so position, think displacement. So far, so good? Okay, so think displacement when we see position. Next, put yourself a point. Label the point 2, 8 right here. And let's go all the way over to, let's say, 10, whatever this is. Okay, so let's, we got 1 point there, and we got another point there. Okay, so this one will be 2, 4, 6, 8, 10. Here we're going to have 4, 8, 12, 16. Okay? Along this axis it's 2 and then 8. So, if the position of an object changed from here to here, okay, changed from those 2 locations, can somebody tell me how I would find the slope of this line? I want to find the slope of this line. How?
Well, you do y minus y, and then
Over.
over x times x.
Good. Now, we always say delta y over delta x, right? Now, what I want you to start thinking about is delta vertical over delta horizontal. I know it sounds weird,
Oh,
but
God.
trust me on this one. Because, and I'll explain in a second, there's a reason it could be a misnomer. So what is my delta vertical? What's my change in the vertical direction?
Which one's vertical?
Remember, vertical like basketball, what's your vertical? Horizontal is like horizon.
Yeah, think of like seeing the sun.
I know it.
From this point to this point, what is my vertical change? coming from? Anyone knows 7?
16 minus 8.
Good. 16 minus 8. Good. This location is at, again, 10, 16. This one was at 2, 8. So my vertical change here, I'll label in black, my vertical change is 8. My horizontal change in this problem. What's my horizontal change? Also 8. Very good. Also 8. Now, what are the units on my vertical change?
Honestly, that was so confusing.
What do you mean, what are the units?
What are the units in 8, this 8? What does it have to do with? Meters, right? You saw this is meters here? What are the units down here for this 8 going to be? Seconds. Now, what's happening here is this. The object moved a position of 8 meters over 8 seconds. So we know that the slope is going to be the vertical change 8 over the horizontal change 8. This is in meters, this is in seconds. What's 8 over 8, everybody?
1.
So,
meter per
1
second.
meter per second. What do you think the slope might actually be indicating if you look at the units alone? What units are in meters per second? Of what variable is that? When you're given meters per second, what variable are we looking at? Speed, or let's use the word velocity. Velocity. Remember, velocity is in meters per second, right? We've done this several times. The last problem was 6.02. It was in meters per second. This velocity here is 1 meter per second. The reason is this. Position really means displacement. So this vertical axis is really like your delta x, your displacement. That's why I was saying before, remember not to call it y and x, because usually you call this y, and usually you call this x, and I don't want you guys to get confused when I put an x up here. This really means displacement. And when you have a displacement over a certain amount of time, you get a velocity out of it. So what you can write down now is this. The slope of a position, versus time graph is velocity. The slope of a position versus time graph is velocity. And think logically now. I'm going to go give you another example. Just look at the board. You don't have to draw this one. If I had another object that started here at the exact same location, started right here at the exact same location, and it ended all the way up here though, after the same amount of time passed. It ended further away. Would it have a higher or lower velocity? Two people, they're running, they start at the same point, and after the same amount of time, this person has gone further. Does this person have a higher or lower velocity, Emily? A higher velocity, again. So two people are racing. This person gets to this location after a few seconds. But this person, who started at the same location, only gets to here after a few seconds. You would say that the first person is running faster, right? Higher velocity. Take a look at the slope. Isn't the slope of this line higher than the slope of this line? Because the slope is the velocity. Again, the slope of your line is always going to be your velocity. Okay, when you have your position versus time graph. Okay, let me give you an example. I might clear it up a little bit. Let's say we have a graph, and let's say we have three objects. Okay, again, we're doing position versus time. Position versus time. Object 1. Object 1. Focus. Object 1 is stationary, like this, standing still. What is the position of the object? Is it changing? Is it increasing? Is it decreasing? Is it remaining the same? It's remaining the same, right? So let's say that this is the origin right here, okay? And I have an object over here at 4 feet apart from the origin, and it's not moving. It's going to remain at 4 feet, whatever this location is. So say it started at 4 feet, it's not moving, it's staying in the same position. What is the slope of that line? What is it? 0. It's 0. Careful. Its location or its height is 4. The slope is 0. The horizontal lines are always 0. The slope is 0 because the velocity is 0. I'm not moving. I'm standing still. I'm stationary. If I'm stationary, my velocity is 0. So the slope of a stationary line or stationary position has got to be 0. Now, if instead though, I start here and I move in the positive direction, I'm increasing my position. That would be like this, increasing my position. Is that slope positive or negative? Positive, it's going up, right? And I'm increasing my position. If I start in the middle again, but instead of doing that, now I decide to go this way. I am decreasing my position. I'm going down. The slope is negative again. So when my position is increasing, my slope is positive. Okay, so slope is positive. Greater than 0 means positive. Here, slope is negative or less than 0. Here, slope is equal to 0. In all these cases, the word slope can be replaced with the word velocity. They are synonymous in this case. Again, whenever you have a position versus time graph, the word slope simply means velocity. Okay? Steph, Helen, Chess.
Isn't the delta vertical axis, that means displacement, so if you're at 4, that means...
You started at 4, and you haven't gone anywhere. Look, the starting point is 4, and you're staying at 4 the whole time. Whereas here, the starting point is 4, and you're going up to say like 10 or 12. Here, the starting point is 4, and you're coming back down to 0.
Oh, so where it ends is like
the final.
where you ended, that's the final, and then how steep the slope is determines how fast you were going.
Exactly. Exactly. It's velocity. Helen?
Say you're not like the first, does that count for like every single quadrant? Say you're in like the third.
Sure, it does actually. Now, you're never going to have negative time, so you would never be in the second or third quadrant, but you could be in the fourth quadrant. For example, watch. If I started here at 4, and the origin is right there, if I go beyond the origin, I'm going into negative territory for displacement. That would mean that I'd be going like this, crossing over the x-axis. This is where I'd cross over that 0 point. So I start at 4 meters, I go back to 0 meters, I cross the x-axis, and I go into negative meter territory, which is negative meters down here.
Oh, okay.
So it can really be in the first and fourth quadrant. Second and third would be negative time. We don't consider negative time. Okay? Chess.
So if you were to like give this as a problem on the test, it'll be like a word problem and then like a graph it, or will we...
Yeah, I might say to you, like, give an example of your motion if you walk from point A to point B and then back to point A. So for that example, if you walk from point A to point B and then back to point A, like that. So let's say you start at point A, whatever point A might be, you walk from point A all the way to point B, but then you walk back to point A, okay? And I'll say, from when you walk to point A to point B, what's your velocity, positive or negative? Well, it's going up, so your velocity is positive. And then it might say, from the time when you turn around and walk backward, what's your velocity? Well, your velocity is negative. And think about it logically. When I walk to point B, it's positive, I'm walking to the right. Then I turn around and I walk back to point A. Now my velocity is negative because I'm moving to the left. Okay? Erica.
Can you think of it as like negative movement because you're going there and you're coming back, so it kind of cancels out?
Yep. Just like yesterday we said negative displacement, right?
Yeah.
Exact same thing.
Okay.
Tristan.
So if it's going left, it will always go down this way.
If an object is moving in the negative direction, it's going to end up sloped down. If an object is moving in the positive direction, it's going to slope up. Yep. Very good. Okay. You okay? All right, let's go on to another problem. All right. I'll write it. Listen carefully. 2 students. Walk in the same
Shoes every day.
direction along a straight path. People stop talking. Come on, you gotta listen. At a constant speed, or let's say constant velocity, really. At a constant velocity. One is 1.5 meters per second. The other 2 meters per second. Okay? So we have two objects or two students walking in the same direction along a straight path at a constant velocity. One is 1.5 meters per second, the other is 2 meters per second. Now, assuming, and this is an assumption we're going to make, that they start at the same time, how much longer does it take the slower student to walk 500 meters? Okay? To walk 500 meters. Can we hold it up for a second, or is it about this? Is it about this? No? Go ahead.
Velocity is interchangeable with velocity is change equals change over time over change over
Change in position over change in time.
what position means velocity.
Position and velocity are related to one another, correct? They are. But remember your formula. Velocity equals change in your position or your displacement over your change in time.
Can you?
You're getting it mixed up right now.
Thank you.
Okay, we got to keep going just for now, Kareem, because we're going to run out of time. The longer problem it looks. We need to go a little faster in this class, guys. I don't mean to be mean as far as intelligence. I mean like less time for stopping for talking. It happens a lot, and we're losing time. I finish the other class every day, but we always run out of time. Okay, we've really got to move a little faster.
Wait, what is that first word on the left? All right, under straight.
One. One is.
Okay.
Again, I'm dictating for a reason. I'm speaking slowly. So you need to write it the first time and not get fall behind. Okay, not just you, Steph, I mean in general. Now, we have two students. One of them, again, is walking slower than the other. So clearly one of them will get there first. Agreed?
Yes.
Now, the question becomes, how much longer does it take one student to get than the other? So what are we looking for in this problem? What quantity? Are we looking for velocity, displacement, or time? Time. Time, time. Okay? How many different times are we going to solve for? Emmett? Two. One student's time it takes, the other student's time it takes. Okay? Now, let's break it up into two parts. We'll do student one over here. This guy has a velocity of 1.5 meters per second. And this person has a velocity of 2 meters per second. Let's call them V1 and V2, please, indicating the first student and the second student. They both walk how far?
500 meters.
And it's the same, correct?
Yeah.
So that we don't need a delta x1 and delta x2, just call it delta x for both. Again, we do not need to specify with a subscript here, simply because they're walking the same distance. Okay? They're both walking 500 meters. The question becomes, though, what is the delta t answer that we're looking for here? With your formula, anybody know a quick way to rearrange this to solve for delta t? To solve this for delta t?
You can multiply both sides with
No.
No, I
Help them out, Adam.
Divide by delta t.
No. Helen.
You would multiply
Math
by,
skills, people.
multiply by delta t and then divide by v.
Very good. That's it. Multiply by delta t. So multiplying by delta t on both sides. You get rid of your delta t and you put a delta t over here now. I didn't mean that. Just put a delta t over here. There's a delta t next to the v, okay? The board is not agreeing. So you have a delta t times v equals delta x. But you need to get delta t by itself, right? So as Helen said, take this v and divide v on both sides, leaving you with delta t equals delta x over v.
Why couldn't you just get rid of the x by delta x by multiplying it? Would that be the same?
Not going to work. Delta x is the numerator. Delta x is the numerator. You cannot multiply by it. You guys got to go back and look over our lessons, okay? I'm not stopping right now. Delta t equals delta x over v. A simple way to remember is you can always rotate the diagonals. Because this is really a proportion, this is really over 1. You can always flip diagonals. So if you took this delta t and put it up here, took the v and put it down here, you would get the same equation. If you don't get it yet, take some time and learn on your own. For now, write it down. We got to keep moving. Now, delta t equals delta x over v. Okay, delta t equals delta x over v. So I take my delta x of 500 and divide it by my velocity. I take my delta x of 500, divide it by the velocity. Here, when you do 500 over 2, you're going to get 250 seconds for your delta t. Over here, though, when you do delta t, you're going to take 500 over 1.5, which is going to give you 333.3 seconds. So student 1 walked slower. Look at his velocity, 1.5. And it took him longer, which is logical. Think about the logic behind your answer. He walked slowly, so it took longer. This student walked faster, so it took less time. How much faster, or how long did it take? What was the difference in these two? What do we do at the final step? Sabilla? Good, subtract the 2. Okay, so what do we get, Helen? What was the number?
83.30.
Good, 83.3 repeating in seconds, which is 1 minute and 23.3 repeating seconds. Okay? Again, the part that people have trouble with or sometimes make mistakes with is rearranging formulas. You got to go back and look at your math work. Okay? Whenever you have a proportion, and let me explain what I meant again by switching diagonals. It's v equals delta x over delta t. That's our starting point. Simply put v over 1. And now it's a proportion. When you have proportions, hold off. Don't put your books away until I'm done, please. I don't like that. When you have a proportion, you can always switch your diagonals. So if you really wanted to move that delta x, like you said, Steph, you would have to move it down here. You can't multiply. It would be divided. So you could just switch these two locations to get delta t by itself. Okay, to get delta t. Tonight, you're going to have homework. It's on Moodle. If you want to write it down, it is page 44. I'll write it on the board so you can see it. It's also on Moodle. Page 44, numbers 1 through 5. That's a 5. And page 47, numbers 1 through 3. Okay, it's going to be a total of 8 problems. Please make sure you work on these, guys. Make sure you look at the sample problems in section 2.1. Read through 2.1 if you have to. There's a lot of resources for you there to look at. If it's multiple choice, oh no, it doesn't matter really if you're around. But if the problem is multiple choice, I want you to understand just a conversion between 83.3 and 1 minute 23. Adios, now, good job. You know what I'm saying now? Yeah. Okay?
Thank you.
You're welcome, guys.